Okay, so at this point we pretty much have the shape node wrapped up. Now what we need to do is create a tighter integration between the transform node and the shape node classes in such that the shape node is taken into account when we do things like search for a node, render out our hierarchy, etc. So there are three different things that we need to add into the TransformNode class so that this integration is all complete and these two classes work together properly. And at that point you can technically say the engine for handling the DAG is finished, and we can then move on to a command system. These three things are: we need to visit find node, because when you're searching for a node, you may be searching for a shape node. So we need to make sure that we check all of our shape nodes as well as our transform nodes. Show tree. It would be nice to go ahead and modify our simple rendering engine so that when we show our tree, we also show associated shape nodes when we're showing all of our transform nodes. And then finally, remove node. When we are removing a node at the moment, a transform node from the hierarchy, everything works great. But as soon as we start getting shape nodes involved, we have that shapes list that's being held in the shape node type object. And because we have that list, well, we end up in a situation where we continue to reference shape nodes. Even though if it may look like they were deleted, we continue to reference them so they haven't been let go. And since shape nodes in turn turn around and reference transform nodes, even though we can remove a transform node from the hierarchy, it's still sitting out there with a way for us to get back to it. And because of that, the garbage collector won't collect it. And Logan will demonstrate this in just a few minutes, and you'll see what's going on and how we will need to fix it. So find node, show tree, and remove node. And once these three things have been addressed, then we'll have the tight integration we're looking for between transform nodes and shape nodes, and at that point we can then move on to commands. So Logan, let's go ahead and start out with something easy. How about the find node?
All right, let's jump to the transform node and then jump up to the find node section.
Okay.
So jumping up, we have, actually it's below set parent, so we have find and find node.
Okay, where at this point in time all we're doing is searching through all of the transform nodes, so we need to add in the ability to also check the shape nodes.
Right. So what I'll do is jump just below the if check and add in an else if. So I can do a check to see if maybe our shape node was the node that we were looking for.
Okay.
Now, before I actually check the name, I need to first make sure that we indeed have a shape node.
That's right.
So the first part of this check will be if this dot shape is not null. And if that is indeed the case, then we can go on and also check to see if this dot shape dot name is equal to the name that we're searching for. Because if that's true, then the result is equal to this dot shape, because this dot shape was the node that we were looking for.
Exactly. And that's pretty much all we need to account for shape nodes inside of our find node method. Okay? So, as a matter of fact, can we demonstrate right now?
Sure.
Let's do it.
We can jump, first let me build and make sure that there's no build errors.
Okay.
We can go into program and just, let's take a look at what we're showing, just so we can make sure that shapes come up. So we can see we do have a handful of shapes. We have, well, ball and box and car. So if we search for box shape, that should show up in a valid search. So let's go into program, jump down to the very end, and let's set up a searching scenario.
Okay.
Let's again make a node variable. Let's call it found node, and set that equal to transformNode dot find box shape.
As we know, there will be a box shape. Okay.
Now let me do an if-else check to see if we found the node or not. So if found node is not null, then let's indicate that it was found. So we'll write out to the console that we found the node, and then just show what node it was. So found node. Otherwise, let's write out to the console that we were unable to find anything. So console.writeLine node not found. So simple enough.
Okay.
So if we run found node box shape.
Okay,
so
now if you go in there and change the spelling, mess it up somehow.
Or even let me just make sure we haven't messed up searching for
Okay.
transforms. We can still find transforms.
Okay.
And then if we said, all right, shape again, once again verifying, okay, shape, and then a messed up shape node, is nothing. It's not found.
Beautiful. So that's working fantastic. So now we can search through all nodes, transform nodes, and all shape nodes to see if a particular node does indeed exist. All right, that's beautiful. Okay, so the next thing we need to do is change up our rendering engine, because right now, when we're rendering out that hierarchy, we're not including our shape nodes in there, and it would be nice to see which shape node is associated with which transform node. So let's go ahead and revisit the show tree method.
Okay, so jumping down a few methods to show tree. Inside of show tree, we are writing out the padding and then the current transform node. We could simply add on to this and say, let's put the shape node in square brackets just after the transform node. So I'm going to add on a space and an opening square bracket. To that we can add on this dot shape, and then finally add on a closing square bracket. Really as simple as that.
Okay.
We can build. Now we can run. Now all of our testing stuff was a transform only, so all of the A through F group was just a transform. That's why we see empty brackets for no shape node.
Exactly.
When we get into the ball, box, and car, we see a ball shape, ball 2 shape, box shape, and car shape.
Do we still have the show all in there from the shape node?
We do over here.
Let's go ahead, down a little bit. We have
a few of them actually.
Yeah, let's go. Well, there's that one.
Oh, okay.
I was just looking for the shape node one. Yeah.
Oh, I got you.
So now if we run, now everything that you see there, this is basically being done from the transform node. So we're not calling upon show all from inside of the shape node. So you can see it's working right. Beautiful. Okay, so the last thing that we need to address is this removing node. And now up to this point, when working with transform nodes, when we say remove this node, it rather remove that transform node from the root nodes list if it was a root node, or from its parent's children list if it was parented to another transform node. And by removing itself from either of those two lists, we no longer had a reference to it or any of its children, any of its descendants, which means at that point, since we have completely lost the ability to gain access to those items again, the garbage collector came around and collected them for us. It was gone. But now we've got all of this linkage going back and forth between shape nodes and our transform nodes. So when we start eliminating our transform nodes, believe it or not, we're still holding we can still get back to those transform nodes through the shape nodes, all the way back to that shapes list if we want to. So because of that, we need to revisit our remove node, and inside the remove node, inside the transform node class, we need to now account for shapes.
Okay, so let's jump into transform node, and let me demonstrate the problem of trying to do a simple remove.
Okay.
Because inside of remove node, the first thing that comes to mind is simply say, okay, well, we're in remove node. That means we're getting rid of ourselves.
So we can go ahead and just kill out our shape too and be done with it.
All right, so let's call upon ShapeNode. Tell it to remove the node this.shape, which makes sense. Just take our shape, remove it from the shapes list.
Okay.
So, of course, that builds just fine. Now, let me put together a test scenario to see if this is indeed working, or if we're getting a lost orphan branch when we try to delete. Inside our program, since this is the last thing we have to address,
I'm
going to go ahead and wipe out most of this example. I'll keep A, B, and C.
Okay.
But everything else I'm going to remove. So we still have A, B, and C. When I said B to A, we'll set C, parented to B, and then everything else can be removed.
Okay.
So now if we do a TransformNode.showAll, we should see A then B then C.
C to B, B to A.
Exactly.
And there we go. C to B, B to A. All right, very good.
Even better, let me
change those over to shape nodes.
Yeah, so that way we have the shape scenario in place. So we'll change all of these to new shape nodes. Now, what's going to happen if I build immediately? A shape node can't be stored in a transform node.
Right.
But a shape node has a transform node that it creates. So even just after creating it, I could say dot transform node, and then we'll store the newly created transform node back in the reference.
Very nice. I like it.
So we can build, we can run, and there we have A, B, and C, and A shape, B shape, shape, and C shape.
Very nice. Excellent. Okay, so let us see this problem.
All right, well, one would assume that if you were to delete... Oh, okay, let me throw one more thing into show.
Sure.
Let's bring the shape nodes show all back into into the mix so we can see the tree hierarchy versus the shape list.
Okay.
There we have the tree hierarchy followed by the shape list.
Okay.
So, let's start out easy. Let me actually do a before and after setup. Let's have a console write line that says before removal, and then an after removal. So let's show before. Let us take, and like I said, do something easy. Let's take node C and tell it to remove node, and then give an after removal. And let me throw an extra new line before after.
Okay.
So very simple, just basically duplicating what we did, but injecting a remove between the two displays. So now we have before removal, A, B, and C with A shape, B shape, and C shape all in the shapes list.
Okay.
That looks good. And then after removal, well, we removed C, so we have A, and then B parented A, and no C, which makes sense because we removed it.
Mm-hmm.
And then same with the shapes. The only shapes we have left are A and B.
Okay.
So just looking at that, it looks like it's working. But let's try something a little more difficult. Let's remove node A.
Right, which technically should reveal an empty hierarchy.
Right, and it should also reveal an empty shapes list.
That's right, everything's
deleted
gone.
the entire branch. So if we run now for removal, ABC, after removal, we don't have any of the hierarchy version. So it looks like the hierarchy branch got wiped out. But look at the shape nodes. B shape remained.
That's right.
C shape remained.
And they're still pointing to TransformNode B and C. So we have this branch of the hierarchy just floating out there in outer space now that we can't get to with the rendering engine to render it out. But we're still referencing it, so it's not going to be picked up by the garbage collector.
Right.
We're referencing it because of this shapes list. So we need to fix it. As a matter of fact, at this point, if you don't mind, Logan, let me just whiteboard real quickly what's going on.
Sure.
So we'll just jump back over here, and let's just throw in another layer real quick. So basically what Logan has done is he has created TransformNode A, which is the parent of TransformNode B, which is the parent of TransformNode C. And A has A shape, B has a link to the shape node B shape, and C has a link to C shape. Okay, now let's do this. Here is our shapes list that's residing in the shape class. That's our static list called shapes. And inside here, we've got A shape, and let's see if I can get that H in there. B shape, and then finally C shape. Okay, and we all know what the linkage looks like with transform nodes A, B, and C, with them being stored rather in the root nodes list, which in this case would be A, and then B and C being stored in their parents' children's list. Okay, so now if we were to come in here and remove out node A, well, node A simply gets removed out of the root nodes list, and we now have no way of getting to B and C as far as our transform node functionality goes. But let's take a look at what happens over here. In that remove node inside the transform node class, when we removed A out, we also said remove the shape node out of the shapes list as well. So this guy got removed. But B and C still exist. And B and C still point to their transform nodes, which of course still point to them. So we still have this relationship, this referencing that's going on, and because of that, these guys are just floating out there. They don't disappear or anything. We just can't get, we can get to them, but we can't get through them or to them through the transform node. We have to actually get to them through our shapes now. Okay? So because of this, we have a problem. And this is what we need to fix. We need to make sure that when we remove a particular node, that we then walk through all of its children, and as we walk through its children, delete out all shape nodes in the branch. Okay? All descendants.
Right, wipe out all shape nodes out of the shapes list, so that after that's accomplished, we can then simply remove the root node that we were looking at to begin with.
That's right.
And once it's being removed from the root list, then it's gone, because the shapes, there's no shapes left to point to it. All of the relevant shapes have been removed, so if you were rendering the shapes list, you would have all those shapes removed. And as far as the hierarchy is concerned, there are no references left to that branch that you deleted, so the branch will get garbage collected.
Exactly. So in this case, we had to walk down and removed out shape A, shape B, and shape C, because they are all in that branch. Okay? So with that, let's go ahead and do a little bit of coding.
All right, let's jump back into Visual Studio and fix this. Let's get into TransformNode, and we now know what we need to have happen. Instead of calling a single remove node, instead we need to be able to call on a function that will recursively remove the node from the entire branch, starting at this current node.
That's right.
So what I'm going to do is write a short method to accomplish this. I'm going to make this method private because there's no need to access this kind of odd tree shape clearing functionality outside of TransformNode. So this is going to be a private void remove shape. What remove shape is going to do is, well, the first thing is it's going to perform the actual shape list removal. So I'm going to simply cut the remove shape line and paste it into remove shape. So that's the first thing remove shape does. But we're going to have it continue on and then recursively go through and remove it from all of its children. So I'm going to put in a for each, which should be rather familiar by now, because what I'm going to do in here is for each transform node child in children. So for each child, I want to call remove shape, or excuse me, remove, there we go, call ourselves, so recursion, and that should be it. Really still pretty simple, and some things we've done several times already.
Yep.
So we make a call to remove shape, which does just that, removes the shape for the current this node. Then it turns around and says, all right, now remove or call ourselves for all children, which will remove all of those shape nodes, and so on and so forth for any node or any shape nodes in the rest of this branch.
Exactly. This is just like the recursion code that we have already taken a look at on the whiteboard, where we just simply continue to call all of our children and their children's nodes. And when calling their nodes, we're calling upon their remove shape functionality. So now we need to make a call to this remove shape method.
So I can jump back to remove node where we were originally removing a single shape, and now we can do a recursive remove. So inside of remove node, we can say this dot
remove shape,
and that will begin by doing the same thing, removing shape, and then continuing on recursively through the rest of the nodes in the branch.
All right, well, let's go ahead and run it because you've got a scenario set up. Let's see if we manage to kill out all of our shape nodes.
If we run, after removal, nothing.
So we told it to remove A, and we did indeed remove A, B, and C in regards to our transform nodes, but we have also removed A shape, B shape, and C shape as well. Beautiful. That's exactly what we were looking for in regards to the functionality it needed to provide.
And a few other quick tests just while we're in here testing stuff is let's try removing at all the other levels. So we could try removing
at
from
B. So that should take B and C out.
So remove A, or leaving only A. And then again, we can just do a final test for C one last time and show that we keep A and B, and C still goes away.
Beautiful. That's it. That is what we were looking for there. So at this point, Logan, I do believe we have got all of our functionality in place. It all seems to be holding up quite nicely for the engine of dealing with the DAG. Everything's there. at this point what we can do is go ahead and demonstrate some very simple extensions of the ShapeNode class into things like geometry and lights, and put a fork in it. Then we can go ahead and move our attention over to a command processing system, which is going to be awesome. So that is going to wrap up this video. Thanks a lot.